Now we are ready to use those 10 rules of Boolean algebra to simplify some Boolean expressions. So let's look at each of these terms initially and see if we can simplify any of them as they are. Now I can see this first term, A ANDed with B. Well, as you already know, A is the same thing as A. It's that rule that we had before, X and X is X. So I can simplify this first guy. I'll just write it as A and B. The second guy, look at that. I have a B and a not B, and perhaps you remember that that is 0. So this is really a 0 and a C. All right. Here I have A, B, and 0. Well, 0 ANDed with something makes it 0. So actually, this whole term is going to be 0. I hope that makes sense. All right, so I'll put 0 down here. And actually, this one's going to come out to be 0 too. But all right, let's go to the next one. I don't think I can simplify that. So here's what I have so far. Now let's just look at 2 terms at a time. Oh, actually, you know what? This guy is also just 0. I'll put 0. Let me just recopy everything here. So I have AB ORed with a 0, ORed with another 0, ORed with ABC. Now, of course, AB ORed with 0 is just the same as AB, so I can really just simplify that as AB. This 0 doesn't do anything either. I mean, this is just ABC. Well, all right. So I'm down to AB and ABC. Now, generally, the strategy is to factor out as much as you can from whatever terms you have. Now, here they both have AB. I can factor this out, just like regular math class. Yeah, this is tricky to students. Now, if I factor out an AB from an AB, I'm left with a 1. So I have a 1 or C, right? That's how you factor, right? If I multiply, if I distribute AB back in, I would get AB times 1, which is AB, AB times C, which is ABC. But anyway, here's what I have. Now, of course, you can simplify 1 or C as just 1. So now I have AB ANDed with a 1, which, of course, is just AB, because that's one of those basic rules. So there you have it. That whole big mess just simplified to AB. All right, hang in there for a couple more. Here is our second example, which we're going to simplify using Boolean algebra. And if I look at each of these terms, it looks like there's really nothing that I can do to any of these terms individually. In other words, I can't just simplify any of these terms on their own. I have to start looking at the terms in pairs. And that's really the general strategy, is you look at 2 terms at a time. You look at 2 terms at a time, and you look for things that they have in common. And I want terms that have everything in common except for one variable. Like these guys both have a WX, so I can factor out a WX, and I'm left with a Y and a not Y, which of course, Y or with not Y is just 1. So this becomes 1 ANDed with WX, which is just WX. So the first 2 terms just simplify to WX. And actually, I can reuse this term or this term with any of the other ones, but let's just see if I can simplify the third term. It actually looks like I can simplify the third term with the fourth term by factoring out a not X, Y, and that leaves me with a W from the first guy and a not W from the next guy, which of course is 1. This is very similar to the other thing, and I have not W or not XY ANDed with 1, which is the same thing as not XY. So far I'm down to these 2 guys. That's pretty good. Let's look at my last term. And again, I can reuse any of these terms up top, but let's see if I can simplify this guy with something. What does it have stuff in common with? Actually, this guy and this guy have 2 things in common, don't they? They both have a not W, so I'm going to factor that out. I'm kind of running out of space here, but they both have a not W and a not X, and that leaves me with a Y and a not Y. Y and not Y, which of course is 1, and I have not WX ANDed with a 1, which is just not WX. So maybe I'm done. Let's see. this is what I have, and let's see. Really, all you can do is just take a look and see if there's anything that anybody has in common that you can factor out. I know you might be tempted to think that wx is the opposite of not w not x, but it is not. And as I look at these terms, I really think I'm done. I don't think there's anything else here that I can factor out. That's it. We're going to do one more example after this, so hang in there. Let's try just one more. So again, I'm just looking at two terms at a time, and I try to see what they have in common. These first two terms, looks like I can factor out a y. So from the first guy, I have an x left. From the second term, I have a not x z. This is the consensus theorem, perhaps you might recognize it as. I have something or other and its opposite with something else. I can just cross out the opposite, and now I can just distribute my y back in here. So I have an x y or y z, and then I'm just going to bring down this last guy here. And this last term is a y not z. Oh, I think I can factor out a y from these guys. So I have a y z or not z left, right, when I factor out the y. This is, of course, 1, right? I have, this is like x or not x, or but in this case it's z. So this is a 1. 1 times y, or 1 and y, is just y. And let me just bring down this first guy again. So I have x, y, or y. Well, now I can just, from these guys, I'm just going to bring it up here. I can factor out a y, and I'm left with an x or 1. This is, of course, just 1. So I have 1 and y, which is just y. Wait a minute. This whole thing just simplifies to y? Oh, yeah, it does. That's it. So it's your turn to give these a try.